Hello and welcome to episode 28 of Let's Talk Transition podcast, where today we were talking to Callum Maxwell, Business Development Manager with Proserv. We had a fascinating conversation about their new ECG system, which is a holistic subsea cable monitoring system, where we found out a little bit about how they're applying that to the offshore wind industry. I found it really interesting, so hope you enjoy it. Hello and welcome to episode 28 of the Let's Talk Transition podcast. I am delighted to be joined by Callum Maxwell, Business Development Manager of Proserv on the renewable side. Welcome, Callum. How are you doing?
I'm doing really well, Dan. Yeah, thanks for having me. I was going to say back, but on the podcast.
We've spoken to you a few times. We've interviewed you at various shows. This is the first time we've kind of sat down and done a podcast. So we do have the benefit of an edit today. So that is something that you'll be happy to hear.
Absolutely.
So we're just kind of 2 weeks ahead of Global Offshore Wind in Manchester, which will be exciting times. Proserv will be exhibiting there and talking about some of the subject matter that we're going to be going through today. But just for the benefit of the audience, if you give us a little bit of background on your own kind of personal journey into offshore wind, that would be great.
Yeah, absolutely no problem. It depends how far you want to go back. I think even when I was in school, I was interested in geography and sustainable development, and that took me on a little bit of a path. Initially through applied chemistry at Strathclyde University, which was great. So shout out Strathclyde University. But I think my goal and my ambition was always to move into the renewables industry, as it was kind of slowly developing around that time. So I went and completed a master's degree in sustainable energy at Glasgow University. And
so
then,
time frame wise, Callum, that was kind of when?
Yeah, so that was about 10 years ago now. I can't actually believe how long ago that was. Then I was working for a while at Glasgow City Council as a business analyst there, and then moved into ship management. So I worked for a commercial ship company, V-Ships. But the goal was always quite clear in my head that it was just slowly plotting a path towards a more kind of technical or business development type role within the offshore renewable market or offshore wind. And after spending a little bit of time in Australia, which was absolutely tremendous, coming back, I had the opportunity to then join the UK's leading research and technology organisation, the Offshore Renewable Energy Capital, as initially a funding proposal specialist, which was great. It gave me a lot of opportunity to work across the supply chain. I would probably describe myself as a little bit of a geek as well. So I like the data and digital innovations. I like the opportunities. I like diving into these little bits and pieces. So then the next step into Proserv came quite organically from a collaboration project between OREC, Proserv, or Proserv's partners, Synaptech, and another partner, BPP Cable Solution, as they started down the development route for what has become the product and service into the market.
So you were actually helping organizations at ORE Capital to develop technology effectively for the renewable sector?
I would say I was the middleman with a really tremendous team of engineers working within the Offshore Renewable Energy Capital. So my role essentially at that time was identify funding opportunities or collaboration opportunities and triangulate the right companies, as in what technologies kind of fit those briefs and where can we hope for the biggest growth with some of these organizations. So that was a tremendous time just to learn about all that kind of leading edge development within the UK supply chain.
And it's quite a challenging role because presumably, everybody was looking at this going, this is a fantastic opportunity for us to make money. We've got an idea. So you really had to kind of separate the wheat from the chaff and decide what could be commercialized effectively.
Yes, not quite so cutthroat perhaps as that, Dan, but there's no matter where an organization is in that kind of let's say technology readiness level, there's a route for them within ORE Capital. So whether it's just it starts off as that conceptual, just great idea, how do I take it to the next level, or whether it's an organization like Proserv is a great example where who have so much experience in the oil and gas industry that are then saying, how can we take the skills and experience that we have and, the thousands of people that we have globally, how can we start to build, or as Davis alludes to it, as a pivot into the renewable sector to enable that sustainable growth within the organisation itself. So if there's a great idea out there and there's willingness from the company to kind of move forward in the offshore wind sector, then the Offshore Renewable Energy Catapult is a great door to chap on.
So then, obviously, Proserv approached you, presumably, to come in. So the next step, if you kind of talk through how you kind of took that role with Proserv and probably how they sold it to you, and did it work out?
I think, touch wood. We'll start with the last question. Yeah, it's absolutely working out. I'm loving working at Proserv and the opportunity that it's given us. But take it back to the start. So I suppose you could say a bit of luck and an opportunity in that Proserv had reached out to say, we have an idea, had been engaging with Synaptech at that time, and I hosted a meeting in the Glasgow office for Offshore Renewable Energy Catapult, or in our offices, to kind of talk through what was at that stage we were defining as the smart cable project. So we initially bidded for an Invite UK smart fund, and we missed out by the skin of our teeth, which set us back to the next round, which unfortunately we were successful in achieving funding for. Then my role at that time was, once it's moved into an active project, I'm on to the next opportunity, the next company to try and support through that process and other avenues. So the ECG development project was very much live and kicking in the background. And as it came to the end of that, I got very kindly approached with Proserv, as I understood the technology, understood what they were trying to do, believed in it, and it felt like the right move at the right time for me. So I suppose in some ways Proserv sold it to me. I think I'd probably already sold it to myself then.
So you mentioned Davis, that's your CEO, Davis Larson.
That's right.
Course, who kind of captained that pivot and diversification into the renewable space. So prior to that, Proserv were largely oil and gas based, one of the leaders in kind of subsea control systems per se. I presume you were probably one of the first people to come in on board and help pioneer that diversification, were you?
Yeah, that makes me sound very special. But yeah, I will happily take that. So I think organizationally, Paul Cook, who's my direct manager, the VP of Renewables, he'd been essentially tasked with a blank sheet of paper. We understood the skills and capability that we had within the organization. So it was, how can we bring that subsea controls experience and that technical skill that we have in developing control systems and general systems that will operate in hostile environments, and take that blank sheet of paper and say, what is a problem that we can use these skills to try and solve in offshore wind? And then from that, there are a couple of other members of the team, Laura Carrigan, who at that stage was a graduate engineer, Lee Davison, who'd been with Proserv for a long time, is now the product manager for the renewables as well. And we are, a relatively tight core team, but we can dip into that great resource and experience that we have from the oil and gas side of the business as well. So so perhaps I was the first, what we call a purist that was enticed across, but in general, there's a great core of capability that we have to kind of enable our transition into offshore wind.
You laugh on the purist side of things, but it certainly was a thing once upon a time, because the renewable crowd were a little bit reticent to let the oil and gas guys come in with a lot of their technology once upon a time. I think that's kind of changed now in terms of everybody working towards the same goal. Would you say that was fair?
I think that's, absolutely a fair comment. I think there's kind of two elements. There's the supply chain part, which obviously Proserv are very much involved with, and then there's the development side as well. So the developers, where we've seen a lot of movement from what we would have previously classed as kind of the oil majors, again, trying to transition and carry out that sustainable growth. And I think, initially there is a little bit of pushback, but ultimately everyone, or the goal in general, is sustainable growth, not just for the organizations, but for longer term, for the country that we live in, for the world that we live in. So I think that movement and that technical expertise can only be a good thing in the long term. And I guess time will tell if that's the case.
Certainly some of the events during the pandemic, or maybe before the pandemic, the macro kind of economic factors, things like the conflicts that were going on at the time, brought into sharp focus the need for energy security for all of the sovereign countries to kind of look at how can we best develop this technology quicker.
Yep.
And I think offshore wind is certainly an area that they're still looking at. How do we make things happen in terms of the planning, the commissioning, and certainly the logistical side. I think there's shortages of equipment, raw materials, as well as looking at how we're moving turbines about from A to B. And I think ScotWind and some of the initiatives that have come off of the back of that have certainly helped to kind of move things forward, but it still needs, I think, looking at. Again, I know Paris recently announced that they were looking to halve the time that from cradle to grave to get to where they needed to be on that. So if we look at the technology itself, ECG, which sounds like a heart monitoring technology, you're clearly keeping your finger on the pulse of your clients to make sure that their equipment is safe. Can you elaborate a little bit on how it works and the benefits to your clients?
Yeah, absolutely. So again, reflecting back on myself, who again is a little bit of a geek, we are a data-focused organization, and the challenge that I think offshore wind has a lot of the time is, are we collecting the right data from the right places? So when we look at some of the statistics, cable failures are very expensive when they take place, and the insurance companies tend to take the brunt of that. I think the latest figures that I've seen are it's still up around 80% of the total value of claims within the offshore wind industry come from cable failures themselves. So it becomes really interesting element of why is that happening? Is it something that we're not seeing? And ECG very simply is trying to give insight totally passively. So using infrastructure that's already within the cables, i.e. the fiber optics within them, to try and understand within the cable section, mechanically, thermally, how is it performing? How do we expect it to perform? How is it changing over 25 years of operational life? And then where Proserv are trying to push it is with our relationship with Synaptech, who've developed a great technology, distributed electrical sensing, which, to put it very, very simply, allows us to take a multimeter to some of the key connections within the turbine infrastructure, or the cable infrastructure, which is the terminations itself. We could also do it in the joints as well, but what makes it interesting is where in your house you take your multimeter away, is once we've got the system installed and connected to the fiber optic network, then those sensors will sit and they will monitor the current, the temperature, the voltage. We can also look at some of the mechanical properties that, as you can imagine, in that offshore environment, there's going to be a lot of fluctuation. And where the market has been for the last few years is not a huge amount of monitoring being carried out at all on intra-array cables, where there can be a lot of failures. On the export cables, the insurance company require simply a DTS system, which is, it's purely focused distributed temperature sensing, as the name implies, on what is the temperature and how can we infer what the conductor temperature is within that, which is a start. However, that's only one thermal bottleneck you're going to be looking at. The other one, which is, potentially has more risk of failure and statistically certainly is more likely to fail, is the terminations themselves, because ultimately these have to be jointed manually. And if there's any imperfection within that, over time, electricity, like water, will find another path. And when that happens, it can be pretty explosive when it does.
So, deliberate or not, it was a piece of marketing genius, the ECG, because you are quite literally keeping the pulse of the patient, as it were.
Exactly.
In real time. And the numbers are quite frightening as well. You said 75 to 80% of insurance claims. So if you convert that monetarily, what does that work out at in terms of the risk to the operator?
Yeah, good. That's a really good question. So there's not been a huge amount of publicised failure rates for offshore wind farms. When we've run, from the figures that we do have from Strathclyde University, when we run that against a wind farm, you're potentially looking at liabilities of hundreds of millions of pounds over the lifetime of an offshore wind farm. And what tends to happen is if there's a failure of an inter-array cable, the approach tends to be just to replace it in its entirety rather than trying to replace a section of it. But where the reason for the cost being so high is a lot of the time you need a very specialised vessel to be able to carry the cable in the first place. And that runs us into the other challenge that we have in the market is vessel availability. And at the moment there's a huge build-out requirement to try and keep up with not just the UK government's ambitions, but globally government's ambitions to try and get more cable, build more interconnectors. And as you touched on earlier, Dan, around that energy security piece, how can you guarantee your supply if you're limited by, a single source, as it were? And what I think is really interesting in the market at the moment is some countries, Belgium's a good example of trying to create meshed grid infrastructure for offshore wind farms. So in the event that you do have a cable failure that will need to be replaced, you can find an alternative path for the power to try and continue to produce and to try and continue to export to the grid. But you need good data to support that as well. And that's really where we're trying to drive it, is better understanding of the health of the critical infrastructure is twofold. Yes, I'm talking a lot about faults and failures. Actually, the bigger upside is how much headroom, as we call it, within a system do you have? So can I, if a turbine's not running at 100%, can I turn the wick up on it? And what will that do thermally to the terminations? How will that affect the cable? Essentially, can it take it? And the reason why that becomes quite interesting as well from an economic perspective of the wind farms themselves is you can trade power up to 30 minutes before you have to export that power into the grid. And as we have more and more offshore wind expected to connect into the grid, you can expect there also to be a lot of fluctuations in terms of energy price. So the better you can understand your assets, the better you'll be able to capitalize on the economic opportunity that will represent as well.
And yeah, I mean, you've skillfully avoided giving me a number, but we're really looking at, in some instances, hundreds of millions of pounds.
Absolutely, yeah.
Over the life cycle of the infrastructure itself.
Yeah, absolutely. So I think based on the figures that we have, again, from Strathclyde University, Offshore Renewable Energy Catapult put out some figures as well, and we've tried to use the data that's available to estimate it, but it is likely to run into hundreds of millions dependent on the size of the project, but that loss of production and downtime due to repairs has a huge impact in terms of profitability of a wind park. And the way a lot of the insurance products are set up at the moment is you can't claim anything for the first 50 days. So you need 50 days downtime before you can put your claim in. And then at that point, the insurers will kind of step in and have to carry some of that cost.
So it really is important to be proactive rather than reactive.
Absolutely. Yep.
When you're looking at these systems.
Totally. And the systems exist now to allow you to be proactive as possible.
And why are cables so much in jeopardy? I mean, it's maybe a silly question, but if you look at the 75 to 80% of the claims are on that, what are the main dangers to cable disruption?
Sure. Well, I think there's probably a number of factors. There's a lot of things that we kind of consider. The bathymetry, I think, as in how the seabed is made up, can be relatively rugged. The cable deburial can be a problem. There's a lot of mechanical stresses that you would expect to go through that cable over the course of its life. From the termination perspective, your challenge is that you're trying to force a lot of variable current through T-boot connectors in most cases, and commonly you've got more than just one set of T-boot connections to export power, to move power through from the turbine, from the nacelle into that cable. There's so many little electrical interfaces that have to be managed really efficiently. And I think sometimes I look at it and I think that maybe the industry's approaching it back to front. So we have, naturally you have a very expensive turbine in place that will have a lot of mechanical monitoring, probably electrical monitoring as well, just to understand how it's performing over time. And actually, when you come to the bottom of the turbine and your switch gear, you're trying to convert that into something that you're exporting through the inter-array cable, is we as a market create a blind spot for ourselves if we're not trying to look in these locations as well. So we have to treat that critical infrastructure, because ultimately if you're in a radio configuration and you lose the first cable or termination, you've lost all the power from that string, all of it. And sometimes I do worry that we're a little bit short-sighted in the fact that, we're not trying to be as proactive as we probably could be in terms of monitoring through. I mean, obviously I've got skin in the game with the ECG system, but it's almost like running your car. And maybe the best analogy is a lot of new cars have like the pressure sensors in your tire. If your tire goes pop, you're going to run into problems, right? So that pressure sensitivity gives you an early warning that your tire is starting to go down and you should probably intervene and do something about it. The alternative approach of not having a system like that in place is you're hurtling down the motorway at 70 miles an hour and you've not noticed that you've got a slow puncture for a while, and then it goes pop and you're in all sorts of trouble. And I think the goal of ECG is really to try and prevent that major failure from taking place by giving the information back to you as a control room operator to say, okay, we've got a problem at this termination, we've got a problem at this termination. It's not at the point it's going to fail yet. So can we build up a campaign that will allow us to have a look, repair what needs to be repaired, and maintain as much production and uptime as we possibly can.
And like all of these things, I think, being proactive, you've got, it's going to be cheaper in the long run.
Exactly.
Addressing the faults as and when they occur, rather than addressing a major blowout further down the line, which causes you all sorts of issues. So just kind of zooming out a little bit from the cable side, looking at the kind of examine the dangers around the cables, and the headwinds there that the ECG system addresses. More widely, looking at the offshore sector, Callum, where do you see the major challenges from a kind of macro viewpoint?
There's a few of them. I think cable landing point seems to be a little bit of a hot topic at the moment. You mentioned that the brands are looking to find ways of accelerating that process through consenting to generating power, which is where everyone should be gearing towards. Where we seem to have hit a little bit of an infrastructural bottleneck is how do we connect all this power to the grid? I think that is critically going to be the next challenge over the next few years. And I think when we look at how the grid is built up, even I suppose when I was in school, which again a long time ago, the national grid probably didn't have the infrastructure at that stage, required a lot of investment. And I think there has been a lot of investment in it, in the grids. I think the kind of major utilities as well are doing a great job of trying to upgrade that grid. But until we're at that point, I think 40 gigawatts would be a lot to try and manage. So there's those challenges. Can you just put some numbers around, if you're able to kind of help people like myself, the layman, understand, offshore wind is going out there trying to bring in X amount of gigawatts that for energy security and requirements for the UK. What is the capacity of the grid at the moment, and what does it need to increase to? The honest answer is I'm not sure. I don't know what our current capacity is at. What I do know is there's a £1 billion project to try and essentially up the capacity of the grids, and all the overhead power lines that we have at the moment across the UK are likely to try and be undergrounded so that we can build a new high voltage network above the ground. So you can imagine the infrastructure and, potentially the disruption that might cause. But because of the gigawatt scale that wind farms are aiming towards over the next 5-10 years, if we don't do that, then ultimately you'll end up in situations where wind farms are generating, have nowhere to sell it, and the taxpayer ends up paying for power that we never get. So I think it is a really critical, I've mentioned it a few times, from a thermal bottleneck, but it's a major infrastructural bottleneck that we have, and people much cleverer than me, I think, are trying to solve that at the moment.
And that presumably lends some fuel to the fire for the oil and gas community, who are, very much, I say the oil and gas, the energy community, who are very much underlining the fact that of the energy mix rather than the kind of switch flicking from one system to another. I think most people that work in the industry understand the importance of running them in parallel for a little while, and it will be a transition and not a hard stop. Would you agree with that?
Yeah, 100%. I think the oil and gas industry, without the raw materials that we get from that, we would grind to a very swift stop. There's so much to it. Again, there's so much skill and capability within the oil and gas market that if we were, to throw the switch, that we would lose a lot of that capability that is more likely to transition over time into the offshore wind market. It's clearly a hot topic politically at the moment about whether there'll be more opportunities for oil and gas in the North Sea. Now, I think from the UK and from the Scottish economy's perspective, it would be maybe a missed opportunity to not look very carefully at it. But let's see how all these things can shake out over the next few months. But I think as we move from where are we at the moment, the mid-2020s somehow, as we move into the mid-2030s, the energy mix is going to look drastically different. So long as we can get and we are solving these challenges that we're talking about. But I'm seeing at the moment that there's a lot of electrical engineering skills being pulled across from other markets as well, because the build out, the rate of build out that we're experiencing offshore wind is just incredible. We need a lot of very, very skilled engineers to come and support that growth as well. So wherever the markets are, wherever those skills exist, I'm sure there'll be opportunities in offshore wind, if not now, then over the coming years as well. So I think it will really support a just transition.
And if we interesting times at the moment with the elections that are going on, both north and south of the border. We've had a number of kind of leasing rounds in offshore wind. What is your feeling about Scotland's position in terms of being a leader in that floating wind space?
I am very excited for what should be Scotland's position. I think it'd be fair to say that we missed the boat from a supply chain perspective on fixed bottom wind. I think that's generally assumed as a fact at this point. So when we look at floating wind, and again, it just seems to fit beautifully for oil and gas organisations, or traditionally oil and gas, now energy companies, to take that capability and help the offshore wind community solve problems that have been solved for 20, 30 years.
Because they already have the infrastructure in place.
Exactly, and the capability and the know-how of how to make these structures exist for longer than perhaps they might have been originally designed to survive in such a harsh environment. No, I'm really excited for it. From an ECG perspective as well, from a Proserv perspective, when cables are unlikely to cause huge problems when your conditions are pretty good. If it stays where it's been buried, you wouldn't expect too many challenges with it unless there's third-party interventions, fishing vessels as an example that might come across a cable will potentially damage it. When it comes to floating wind, the dynamic cable question is just so interesting. First and foremost, how do you ensure that cable that's now in the water column is engaging with its environment the way that you've designed it to and the way that you've simulated it to? And again, there's some systems out there that can support it. Maybe a shout out as well to our colleagues at Sonardyne, who quite well. Their kind of externally mounted sensors will give you an indication of where within the water column that cable exists. So you can start to kind of validate your model from there. But ultimately, you need to try and get as many metrics and as many ways of looking at that cable to ensure that it's operating the way that you expect it to. And again, there's a lot of context around it as well. Whereas the sea conditions, the wind conditions, all of it is likely to have an impact on the how that cable is moving within that water column. So reference it back, I find these sort of technical challenges really, really interesting. And the more data that we can collect and dare I say it, share across the industry, then the more robust their designs will get, the more that, we can start to look how far can we push these assets and generate the most for.
So you're very optimistic for Scotland's future, but not without its challenges.
Totally. Yeah, I'm an eternal optimist, so absolutely I'm optimistic about it. I think we've got a huge opportunity to make the most of the supply chain that we have to hand. I think maybe that's one point of not quite contention, but what would be great, I think, from the supply chain is to have a better understanding of what local content really means and how does that allow organisations within, Scotland, but the UK more generally, how does that allow us to compete on a more even footing than manufacturing processes that might be a little bit cheaper on the kind of far side of the world. So a bit of assurance on that side, something that's more mandated and less, let's just say is more mandated centrally and understood as part of a scoring system to engage with some of these great opportunities would be valuable.
And if you had, hypothetically, of course, if you had the chance to whisper in the ear of some of these candidates that were standing for election, what advice would you give them as far as how they might be able to help the industry move forward at the pace that it needs?
Yeah, good question. I think the industry tends to have the answers to a lot of the questions that we have. I think there's still a behavioural piece and working with local communities. There's only so many places across the UK that will be really suitable for cable landing points, and that is going to cause a lot of disruption, I think, to those local communities. So we need to understand how to engage effectively to show the benefits that it can give those local communities, so that maybe that becomes a focal point for the government talks about levelling up campaigns. I dare say there'll be similar policies in place no matter who's in government in a few weeks. I think it's this understanding who's and having empathy towards the people that are most likely to be put out by these infrastructure changes and supporting them through it and making sure that they benefit greatly from it, which I think for fixed bottom wind, again, we missed that opportunity.
So incentivizing the communities commercially, potentially.
Yeah, I think so. Socially, commercially, and hopefully in every sense that we can, and allow these these people, these little communities to be part of what is going to be a great transition for Scotland, for the UK as well.
Perfect. So more generally then, what can we look forward to as far as Proserv is concerned in the future?
Well, so ECG started off its life as electro cable guard. Our focus was and remains still firmly on cables and the health of the cable system and terminations. But as we were chatting before this, Dan, you correctly alluded that we've slightly moved away from the full definition and focused more on the finger on the pulse. And I think the idea is the ambition is to take the insights that we're able to get from the sensors that we have and see where else across the turbine infrastructure that can add value. And that's really interesting for us from like the pure background that Proserv have in terms of controls technology. We've put a great focus on what we can do in terms of floating wind market, in terms of control systems, automated control systems. How can we develop systems that allow us to dynamically make the most of the wind resource that we have, despite what is likely to be unfavourable sea conditions at the same time? And that's really interesting technical challenge for us as well. So we're trying to broaden beyond just the cable and electrical infrastructure into some of the more mechanical pieces and on the turbine themselves. And I think it's going to be a really interesting, exciting couple of years for us, and hopefully we'll have some exciting announcements to make at Global Offshore Wind.
All right. Okay. I will keep my ears to the ground on that one. So more interesting ways to use the data that you're collecting and applying it in different ways across the ecosystem by the sounds of things from what you're saying.
Yep.
So I think that pretty much wraps it up. But to kind of circle back on the kind of first question that I asked you in terms of how you started your career, what advice would you have to young graduates looking to get into the offshore wind industry itself, and maybe drawing on some of the experience that you've encountered yourself?
But it's a great question. I was thinking about this earlier, and I think the crux of it is to trust your gut. And if it's a market that you want to work within, then there will be a role within it. So my next point is, don't worry too much about the role, because everyone plays a really important part in ultimately generating power, whether you're in the supply chain company, whether you're working for a developer, whether you're working for an EPCI organization. So if that's where your passion is, then just follow it and see where it takes you. I was very fortunate to have the opportunity to work for the Offshore Renewable Energy Catapult, which directly gave me exposure to so many different technologies, organizations, people, connections. And I think that has been a huge help in my career. Ultimately, I think when I was in university finishing my master's, did I expect to specifically be within a sales or business development role? No, but it's amazing where life takes you, and you have to take the opportunities that you're offered, and I absolutely love it. So again, a lot of people say, what are you going to do next, or what do you want to be? It's easier to say what industry you want to work in, and then the rest will organize itself, I think.
Great advice. I think a lot of parents watching this struggle with that question, advising their children on where to go. Everywhere seems to have its challenges at the moment, but I think trusting your gut is good. I think clean energy clearly over the next 10 years, it will become the predominant industry for the energy sector globally. And it's noticed when we were doing some work in Africa recently, Kenya is now 80% powered by renewables, which was a complete news to me, but very interesting to hear. And that's now the case with some countries in South America.
Yeah.
And I think Europe isn't too far behind on that once they overcome their logistical challenges. So thank you so much for being our guest today, Callum, for episode number 28. We wish you well for Global Offshore Wind. I'm sure our team will be talking to you again shortly for some of those exclusive pieces of news.
Fingers crossed. Yes, thanks, Dan. Really appreciate the time. Thank you for having me on. And yeah, please, if you're attending Global Offshore Wind, please pop by the stand and we can have a conversation.
All right. Bye for now. Thanks, Callum.
Thank you.